So this is the 50th session on relative velocity. In this session, we'll take up two numerical problems on relative velocity for translating frames, in which the relevant condition which I'll specify just now. Okay, it is just case 3. Fine. Case 3 of 40. Case 3 of 47th video. Okay. 47th video you get case 3. So from that it is alright. So these are the two frames, F and M. M is translating with respect to F. P is a moving point. Okay. So VPF, by that formula for translating frames, VPF equal to VPM plus VMF. Now in this problem we'll take up a problem in which this is known fully, magnitude and direction both. Of this only magnitude is known and this only direction is known. Okay, so this I just stated for the sake of we don't have to go to the previous video. Fine. Okay, so I'll write down the problem. So this I'll write it. Okay. So I'll write down the question, okay? There is a straight river which flows towards east. At a constant speed of u with respect to ground. Alright. P1 and P2 are two vertical poles. Two vertical poles fixed in the river bed. Such that P2 is 60 degree north of east. This 60 degree north of east with respect to P1 and L is the distance between these poles. L is the distance between these poles. S is a swimmer whose swimming speed with respect to river is u root 3. Okay. The swimmer swims from P1 to P2 and then back to P1. Find the time taken by the swimmer for complete journey. Okay, this is the question. All right. So this I'll grab it. Okay. So first I will draw the diagram, okay. Before that we will specify what is the observation, object under consideration, swimmer. Swimmer is on the observation, denoted by S. Instead of frame M we have river frame, denoted by R. Instead of frame F we have ground frame, denoted by G. Alright. Then I draw the top view of the situation, top view. This is the south bank, this is the north bank of the river. River flows at a constant speed u with respect to ground. These are the two poles P1 and P2 fixed in the river bed, vertical poles. L is the separation between these two poles. And P2 is 60 degree north of east with respect to P1. So this angle is equal to 60 degree. Okay. Also, VRG is given to be U, eastward, constant in magnitude and direction both. VSR is the velocity of swimmer with respect to river. That is given to be U root 3. Okay. So this is the complete information I have told you. Now swimmer swims from P1 to P2 and then back to P1. Let T be the total time taken by the swimmer which has been asked to calculate. So now where to start to find T? See, in such questions, if the question is long, then you must decide from where to start the question, okay? What is the first equation to be written down? Then you will get the path, you follow the path, okay? So T is the total time taken by swimmer to swim from P1 to P2 and then back to P1. So T will be equal to T1 plus T2. T1 is the time taken by the swimmer to swim from P1 to P2 and T2 is the time taken by the swimmer to swim from P2 to P1. Now to find T, we have to first determine T1. So T1 is the time taken by swimmer to swim from P1 to P2. That is T1. Alright. Time taken by swimmer to swim from P1 to P2. Now when swimmer swims from P1 to P2, he moves a distance of L with respect to ground at a constant speed equal to VSG1 say with respect to ground. So time taken is distance by speed. L by VSG1. L is known. To find T1 we have to know VSG1. Now to know VSG1 we write down the vector equation for translating frames. VSG1 is equal to VSR1 plus VRG. Now VRG is U, magnitude eastward, magnitude direction both known. VSR1 is U root 3, magnitude known. VSG1 direction is known, P1 to P2. So it's again a problem of case 3. Third case problem, alright. Now what we have to do? You please go back to the previous videos, 3 to 4 to 5 videos, you get everything, case 1, case 2, case 3. Okay, you search it, fine. This is case 3, alright. Now what we do, we draw the vector diagram. To find VSG1, we have to draw the vector diagram. Now we know the direction of this and this, so we draw these two vectors with their tail coincident. So this is VRG, this is U eastward. Now VSG1 is 60 degree north of east. So I draw this VSG1. Now it remains to draw VSR1. VSR1 will be drawn in such a way so the tail of this coincides with the tail of these two. And it will be drawn on the side of VSG1 not containing this but on this side. So this is VSR1 which is simply U root 3. Now with these are the adjacent sides and these are diagonal, I complete the parallelogram. While completing the parallelogram, you adjust the side lengths so that diagram is drawn properly. So this I will shorten this diagram till here. Alright. So this angle is how much? 60 degree. Let us call this angle is say what? Theta. Alright. This I draw now. This I will rub it. So, as discussed in 49th video, VSG1 will be written as u root 3 cos theta plus u cos 60 degree, u by 2. Cos 60 degree is half. Now to find VSG1 we must know theta. For that again we use the concept discussed in the 49th video. U root 3 sin theta will be equal to u sin 60 degree. Component of these two vectors resultant of these two vectors is in this direction. In direction normal to this, components of these two cancel out. So u root 3 sin theta is equal to u sin 60 degree. So u root 3 sin theta is equal to u sin 60 degree. Sin 60 degree becomes root 3 by 2. So u and u will go away, root 3 will go away. So sin theta becomes half. So theta becomes 30 degree. Now we substitute the value of theta in this equation. So VSG1 becomes u root 3 into cos 30 degree. Cos 30 degree is root 3 by 2 plus u by 2. 3u by 2 plus u by 2, 4u by 2. 4u by 2 and 2u. So VSG1 becomes 2u. Alright. Substitute the value of DS1 in the, now we go back, we reverse, okay? Backtrack, okay? Now we substitute the value of VSG1 in this. So T1 becomes L by 2u. Alright. So to find T1, you have to know T1 and T2. T1 you already determined. Now again you go ahead. Now to find T2. T2 is the time taken by the swimmer to swim from P2 to P1. So when swimmer swims from P2 to P1, he covers a distance of L with respect to ground frame at a constant speed of VSG2 say with respect to ground. So time taken is distance by speed. L by VSG2. Now to find T2 we must know VSG2. Okay. Again to find VSG2 we write down the vector equation as we did in first VSG1 case. Alright. So what do we write? VSG2 is equal to, translating from formula, VSR2 plus VRG. Alright. This I'll write it, okay? So now what we see, we know VRG fully, U is toward magnitude direction both known. For this VSR2, you know the magnitude, U root 3, direction not known. This we know the direction, but magnitude not known. Therefore, it is again a problem of case 3. Alright, fine. So now what do we do? We again draw the vector diagram first. Now we draw the arrows of these two vectors whose directions are known with the tails coinciding. So VRG is in this direction, U. Now I draw the vector VSG2 whose tail coincides with this VRG. So this is VSG2. VSG2, this is VSG2. And we know this angle is 60 degree. Now we have to draw the vector VSR2. Now we draw the vector VSR2 in such a way so that the tail coincides with the tail of these two. And it is drawn on the side of VSG2 not containing this VRG. It is on this side. Like this. This is VSR2 U root 3 and this is VSG2. This I'll write it here for the sake of clarity. This is VSG2. This angle is say phi. Now this is the diagram of the parallelogram. These are the two adjacent sides. We complete the parallelogram. Okay. Now this is 60 degrees. So this is interior angle. It is 120 degree. All right. Now we have to know VSG2, magnitude of VSG2. For that, what do we write? VSG2 is equal to U cos 120 plus U root 3 cos phi plus u cos 120 degree. Cos 120 degree is minus half. Now to know VSG2 we must know phi. What we have to do? Component of these two in normal direction, in direction normal to this, in this direction, cancel out. So u sin 120 degree is equal to u root 3 into sin phi. U goes away, sin 120 degree becomes root 3 by 2 is equal to root 3 sin phi. So this means sin phi is half. Phi means 30 degree. Now we will substitute phi in this equation. So VSG2 becomes u root 3 into cos phi. Cos 30 degree is root 3 by 2 and u minus u by 2. This becomes 3u by 2 minus u by 2, 2u by 2, that is u. Okay. Now substitute VSG2 in this equation. So T2 is known. L by u, this is T2. And T1 is how much? L by 2u. Now what we do? We add these two to get the required answer. Alright. If we add these two, we get the required answer. This side up, okay. So total time t is equal to t1 plus t2. t1 was found to be L by 2u and t2 is found to be L by u. So add up to 3L by 2u is the required answer. Alright, fine. So one question on this has been solved, okay. Now I take one more problem on this 50th session, okay. Now I take up one more numerical problem on relative velocity, okay, for translating frames in this session. So first I write down the question, okay. A straight river width L flows towards east at a speed u with respect to ground, okay. S is a swimmer whose swimming speed with respect to river is 2u. Whose swimming speed with respect to river is how much? 2u. Whose swimming speed with respect to river is 2u. S is initially at a point on the south bank and swims across the river to a point on the north bank. The drift of the swimmer drift of the swimmer is found to be D. Find the time taken by the swimmer to cross the river by two different methods. Okay. These are rabbit, okay. So I'll draw the diagram, okay. First of all, instead of swimmer we have S as stated in the question. Instead of M frame we have the river frame denoted by R. Instead of F frame we have the ground frame denoted by G. Alright. Now we draw the diagram of the situation. This is the river, top view of the river. Width is L. This is the south bank, this is the north bank. Swimmer starts from the point on the south bank and swims across the river to the point on the north bank, such that the drift of the swimmer is given to be D. As discussed in previous videos, drift D, this is the drift D of the swimmer in diagram. This is the initial location of swimmer, this is the final location of the swimmer. And this is L. Then what I do, I write down the vector equation for translating frame. River is translating with respect to ground. So VSG is equal to VSR plus VRG. Now VRG is fully known. U eastward, magnitude and direction both known. VSR you know the magnitude 2U, but direction not known. And VSG we know the direction. It is from this point to this point. So the drift is D, L is the width. So this angle alpha is known. This will be tan alpha will be L by D. So in one way VSG is known. VSG is directed from this point to this point in this direction. So direction of VSG is known. Magnitude of VSR is known, but not its direction. And we know fully VRG, magnitude and direction both. Therefore it's a problem again of case 3. Okay. So now what we have to do, we have to find the time taken by swimmer to complete the journey by two different methods. So method 1. First method. Okay. Method 1. Let T be the time taken by the swimmer to cross the river. Swimmer moves from here to here. In a straight line, the swimmer moves at a constant speed of VSG. The time taken is distance covered by swimmer with respect to ground divided by VSG, distance by speed. Now distance covered is this straight line distance. This is a right angle triangle. This is L, this is D, this is also L. This is root under L square plus D square. So time taken is distance covered with respect to ground L square plus D square divided by VSG, speed of swimmer with respect to ground. This is the time taken. Now we have to know VSG. L and D are known. We have to find T, we must know VSG. Okay. Now how to find VSG is the question. For that I write down the vector, this vector equation I have already written. I draw the vector diagram. I draw the vector diagram in this here itself. I will draw it here. First we know to draw the arrow of the vectors VSG and VRG with their tails coinciding. VRG is in this direction U. VSG is in this direction. This is VSG. This is alpha. Now we have to draw the arrow for the vector VSR. The tail of VSR is made to coincide with tails of these two. And it is drawn on the side of VSG not containing this VRG. It is on this side. So this is VSR to U. Now with this adjacent sides, I complete the parallelogram so that this is the diagonal. Okay, fine. This is VSG, this is VSR, this is VRG. Let us call this angle as beta. Okay, fine. Now tan alpha is known from this diagram. See, this is right angle triangle. This is D, this is L. Tan alpha is equal to how much? D by L. This is tan alpha. Fine. Sorry, L by D. Sorry. Tan alpha is L by D. Sorry, not D by L, but L by D. Okay. So now what we have to do? We have to know VSG. Okay. VSG. If you know VSG, problem will be solved. So as discussed in the previous videos, VSG will get it. VSG will be equal to U cos alpha plus 2U cos beta. Now to find VSG, we must know alpha and beta, but alpha is known. Tan alpha is L by D, so cos alpha can be found out. Now we only have to know beta. The resultant of these two is in this direction. In direction normal to VSG, components of these two vectors will cancel each other. 2U sin beta is equal to U sin alpha. 2U sin beta is equal to U sin alpha. 2 and U cancel out. So sin beta is half sin alpha. Okay, fine. Sin beta is how much? Half sin alpha. Now I love this, okay? So substitute in this. So VSG becomes U. Now tan alpha is how much? Tan alpha is just equal to L by D. So cos alpha becomes how much? D by root L square plus D square plus 2U cos beta. Cos beta is root under 1 minus sin square beta. Sin beta is 1 by 4 sin square alpha. Alright. So this becomes UD by root under L square plus D square plus 2U root under 1 minus 1 by 4. Now tan alpha is how much? Tan alpha is L by D. So sin alpha becomes how much? L square by L square plus D square. Okay. So this is VSG. If we 2 we insert inside this, then it becomes UD plus U times root under 4 minus L square by L square plus D square. Alright. UD plus U times root under 3L square plus 4D square upon root under L square plus D square. Alright. So this is the value of VSG. Substitute in this one. So T will be how much? Root L square plus D square upon this. If we substitute this in this one and simplify, then T will be how much? L square plus D square by U common root under 3L square plus 4D square plus D. This is the required value of T. See, this is the required answer. This is therefore the required answer. Alright. So T becomes L square plus D square by L square plus D square. L square plus D square by U times root under D plus root 3L square plus 4D square. This is the required time by method 1. Alright. I'll wrap this, okay? Now I'll discuss this problem by method 2. See, method 2 you must remember in the previous videos. In the 47th video, 47th. I discussed the time taken by the swimmer to cross the river can be found by another method. And that method is this. Time taken by swimmer to cross the river is T barabar width of the river L by component of VSR normal to river flow direction. Component of VSR normal to the river flow direction. Okay. Now, In this, we have to find the component of VSR normal to reverse flow direction. Okay, this is it's like this. As I drawn the vector diagram just now, this is the vector VSG, this is the vector VRGU, this is the vector VSR, this is alpha, this is beta. Component of VSR normal to reverse flow direction is VSR sin alpha plus beta. So VSR perpendicular becomes 2u sin alpha plus beta. Alright, so this becomes 2u sin alpha cos beta plus cos alpha sin beta. Alright, now we know tan cos alpha sin alpha cos alpha we know. Sin beta also we have just determined using method 1 that we can use the result. Okay, so this I will rub here. Okay, so now tan alpha is how much? As I calculated just now, sin beta was how much? Sin beta was half sin alpha. Sin beta was half sin what? Alpha. I hope you remember it. Okay. So I substitute in this one. So VSR perpendicular becomes how much? 2u sin alpha. Tan alpha is how much? Tan alpha is equal to L by D. So sin alpha becomes L by root L square plus D square into cos beta. Cos beta becomes how much? 1 minus sin square beta. Sin square beta is what? Sin square alpha by 4 plus this bracket inside plus cos alpha. Tan alpha is how much? L by D. Cos alpha becomes how much? D by root L square plus D square into sin beta. Sin beta is what? Half sin alpha. Sin alpha is what? Sin alpha is equal to L by root L square plus D square. Okay, this VSR perpendicular. Fine. So on simplifying this, how much this will come out to be? I take this outside. This I take outside. U by root under L square plus D square, and 2 I insert this L 4 minus sin square alpha. 4 goes here, sin square alpha. Sin square alpha becomes how much? L square by L square plus D square plus U, and this 2 also I have inserted here. This comes outside. Okay. So U also is this. Okay, fine. 2 I here. So this also I take it out here. This I take it out. 2 I insert this plus D plus D. Okay, fine. D into L. Okay, L. Okay, okay, fine. U by this 2 I take in U by this size, and 2. Yes, okay, fine. Okay, so this becomes how much? And this is one still remains here. So this, if you take this outside here, this becomes U square by L square plus D square. Okay, and this becomes L root 3L square plus 4D square plus LD. Okay, the VSR perpendicular. Substitute in this formula. So T becomes how much? L by this. So L by LU by U square 4D square plus D. Okay, so L goes away. Answer comes how much? L square plus D square by U D plus root under. This is the required answer by method 2. Okay, so same answer we have obtained by method 2 also. Fine. This was the 50th session on relative velocity. I took up this problem for case 3. In next videos I will discuss some more problems on case 3. Then I will pass over to case 4. Fine. Then this chapter will be finished. Okay. So I close this here by itself. Okay. Fine.